Again, sorry about the air conditioner noise. It is warm today. Let's see. So let's talk about Arduinos. So what makes an Arduino an Arduino? There's basically an atmel part, and the atmel part all by itself is totally usable. You don't need Arduino stuff. You can program it directly. You can use it directly. You can program it in assembly. You can program it in C. You can program it in whatever. Arduino's nice because it adds some extensions to the C library, so it makes it a little easier to use. But one of the big things that makes it easy is this USB connector. So you can use a USB connector to connect it to your computer instead of the way that the chip was actually designed for originally. So the way the chip is designed is it has a SPIE, an SPI interface, SPI, serial protocol interface, I think, something like that. It has a reset line and data in, data out, and clock. So it's a serial, non-bidirectional. So there's a data in, data out, and there's a clock. And this is the way the chip's actually meant to be programmed. And you can certainly use the chips this way. You need a programmer. You can't hook it up directly to your computer because it's SPI and your computer doesn't know how to do that. But you can certainly program it, and it's not that hard, but it's a little more work than maybe the average Joe wants to do. So what the Arduino community said was, let's go ahead and make the Arduino itself USB compatible. And so it won't do that automatically, so they put in an extra chip, okay? So on the back side of the board, on the Nano, there's an HC340 chip, and that chip is a USB to serial conversion chip. And they take the serial lines TX and RX, and they run that into the TX and RX for the ATmega. Now, when the ATmega wakes up, it's not listening to TX and RX. This thing won't work, and so you actually have to have software in the ATmega, so when it wakes up, it's looking at those two lines and seeing if you want to program or not. And that's what's called the bootloader. So if you have an Arduino, it has a piece of code called the bootloader, and that's kind of the heart of its programming. And the bootloader looks to see if there's any data transmissions on these lines, and it says, oh, I guess they want to program, and we'll talk over this USB with these serial lines, and so it does all of that. Now, so why do I bring this up? Well, in my test board, I want to use the entire port, the D port. I want to use all 8 lines of the D port. And data 0 and data 1 are actually TX and RX. And I want to use those as output, okay? So I want to actually output those because I'm going to use the other 6 lines, 1, 2, 3, 4, 5, 6. So I want to use all 8 lines of the D port. And unfortunately, and I hadn't remembered this, the transmit line is fine because it's going into an input on this pin, but the receive line, there's actually an output on the C40 chip, and that output is going to RX. Well, if I program RX to be an output, I have an output and an output crashing into one another. So that's not going to work. So how do I get around that? Well, easy thing to do is let's just get rid of that, okay? And so that's what I've done. Here is my part, and this is the Nano. And on the back side, there used to be a chip there, and I have surgically removed it. So there's no more chip on the back side. So I have lobotomized my USB capability. So the USB will no longer work on this Arduino Nano. But fortunately, the people who laid out the PC board gives you a 6-pin connector on the end here, and that is this. It has power and ground, reset, data in, data out, and clock. And so the SPI comes out this connector. And so we don't need this chip to program if we want to ignore the USB. We can go ahead and program it with the SPI port using these 6 pins. And so I am going to, let me zoom out a bit. I'm going to take my board, I'll put this back in it, and we will now have a USB-less Nano, but we'll be able to use the SPI port. So does it take some type of complicated equipment to do this? No. You get yourself one of these USB tiny programmers. These are probably a couple bucks these days on eBay. And it has a chip. In fact, it has two chips, but it has a USB connector on this, and it has a 6-pin connector on the other end of this ribbon cable. So, in order to program the card, you plug the ribbon cable into here, you put your USB connector into here, and now your Arduino development system can now develop just fine. Instead of programming with USB, you need to go and use the programmer. In the Arduino software development system, there's a pull-down menu where you can say download from bootloader, or download bootloader, which is how the bootloader gets in there in the first place with the SPI, but it says download using programmer, and you can do downloading using programmer, and you can use the system exactly as is. So we don't need USB any longer, and now my two lines don't conflict with one another, and maybe that will solve our problem here. So let's go ahead and get this thing up and running again. I'll solder this board back in, and let's see if that fixes our problem with this chip. Well, I've tried everything. Made sure that all the lines are good signals. I saw that one problem with RX and TX. Got rid of that. I monitored every single line. They look completely clean. So there must be some type of programming error for this chip. So I'm going to go and take a look at that. Or it might just be a dead chip. Maybe that's why I have these in my possession, is maybe these were rejects, and when I took them out of the trash can, they should have been in the trash can. I don't know, so I'll have to work on that. It is working good though on the Osram part, working just fine, and I think that's what I'll use in my next project, which I have in mind. And so the test board is doing, I guess, what it's supposed to do. I'm not sure why it doesn't talk to these guys yet, but it did allow me to test the 10 units that I bought off the eBay, and they all work just great.